limitation uh, the limitations that come up with using such models. And I'll also talk about a bit about some of the approaches we can use to overcome some of these limitations. Not fully overcome, but at least to kind of improve upon some of these limitations. So as Krista mentioned, I have multiple hats. I work as a professor at UCL, and at the same time I work as an Amazon scholar with the Alexa team at Amazon. The work that I'll be presenting today is mainly based on my research at UCL. The work at Amazon is separate. So why did I choose to talk about using large language models for evaluation? Basically, there is a growing evaluation bottleneck in the development of models. As you know, AI systems are commonly being used across many diverse tasks. Especially during the last few years, we started using AI for almost everything. And before these AI-based systems are deployed in practice, we have to get an idea about how the quality of these systems. We wouldn't want to deploy or show to the users systems that don't look reasonably good. And because of this need, we would need some evaluation mechanisms to be able to quantify the quality of these systems. And many such evaluation tasks require annotations. And possibly these evaluation needs don't really just finish at once when one system is deployed. Quite often these systems are regularly updated, so we would need to reevaluate and continue the development cycle over time, and each time reevaluate the updated model. And this comes, of course, with the need for extensive annotations. And traditional approach for obtaining these annotations was based on using humans, which is quite expensive and time consuming. And it's expensive both in terms of time and money because expert annotators require extensive training and guidelines. Developing these human annotation pipelines require extensive effort from both the experts who require the judging task, but also extensive time in training these annotators. And also annotating each of these examples one by one also takes significant amount of time from expert annotators, which is very expensive. And because of that, traditionally, even major companies had to allocate millions of dollars each year for the human annotation tasks. And also, it would significantly delay the deployment cycle because you have developed a new model, you would need to wait until you have significant amount of human annotation available to be able to evaluate the quality of these models before you can deploy these models. So it's a major bottleneck in general. And I'm talking about this, but a lot of you who are aware of LLM as a judge, who have been, I'm sure who have been using LLM as a judge, you may say, oh, why human annotation? Just use LLM as a judge. It has now become such a standard approach used by many different people. And LLM as a judge has many opportunities, has many advantages over using human annotation, but it also comes with lots of limitations. And in today's talk, I will try to address this issue about why use human annotation at all and why not just throw an LLM as a judge and use it. Is this a valid approach? Because I do see it a lot in both in people working in the industry when they would like to evaluate quality of a new system, they directly say, okay, I will create an LLM as a judge and ask LLM as a judge to give me some annotations, and that's it. And I also see it in students writing research papers or researchers working on research publications where they create a new model, they just use an LLM as a judge without really questioning the reliability of the annotations obtained from LLM as a judge. So in today's talk, I will try to talk about these opportunities, emphasize them. Of course, it's a great advantage. I think they have great potential, but I'll also try to focus on these limitations so that everyone is aware of what type of things we should think about when using LLM as a judge. And instead of just using LLM as a judge as is, first trying to understand the reliability for the task and the quality of the annotations obtained from LLM as a judge so that we can basically improve the quality if needed, and furthermore so that we don't make any wrong ship decisions or any wrong decisions in terms of when we evaluate the quality of the models we build. First, advantages of using LLM as a judge. There are these well-known advantages that lots of people are aware of, and these are the main reasons why people usually use LLM as a judge, actually. There are these well-known advantages over human annotation. First of all, of course, they are scalable, meaning we can evaluate thousands of outputs very quickly, and this could be a very big advantage because especially for this type of bottlenecks that I mentioned, when you have developed a new model, you would like to very quickly get an idea. You would like to use maybe these annotations for fine-tuning or improving these models, or you would like to see the potential of these models when real users see it and try to make these decisions very quickly. So scalability is a big advantage compared to human annotation. And they tend to be cheaper in the sense that first of all, time-wise, of course, because these judgments are much more scalable, you don't need to spend as much time as waiting for human annotations. And also you don't need to go through this extensive training that is often required when you use expert annotators to get high quality judgments, for instance. And they tend to be also cheaper in terms of money, although there are some recent debates. I know people are talking about AI being sometimes more expensive than human labor, for instance, recently. But often, depending on the type of models you use and the architectures you use, financially they tend to be also cheaper. There are also less known advantages of using LLM as a judge. One is, of course, flexibility. Using an LLM as a judge, you can very quickly adapt to changing judging criteria by just updating prompts or just fine-tuning these models. And quite often, when you see annotation results or the judging guidelines, quite often tends to change. And sometimes when you use expert annotators, human annotators, you would need to retrain possibly, especially for major changes. Expert annotators have to be retrained, and it's not easy to make changes in judging criteria. Even small changes in judging criteria may possibly confuse expert human annotators who have already been used to some other judging criteria, for instance. So flexibility in adapting to judging criteria is a big advantage when using LLM as a judge. Another big advantage is avoiding fatigue and human subjectivity. We as humans, of course, tend to over time get tired, and there is only certain limit we can do. And in fact, the quality of judgments obtained by humans, depending on how much time they've spent on the annotation process, could become worse over time. So they would need to pause, and they would need to basically refresh. And so that's one issue that we wouldn't face because LLM as a judge, in a sense, is a machine, and you wouldn't face this type of fatigue problems that you might face with using humans. And human subjectivity, to some extent, also you could avoid it because when using an LLM as a judge, um, the subjectivity when there is some variation in using LLM as a judge. When you give the same instructions to the model, you might get possibly some different outputs, but human subjectivity is less of a problem when you're using LLM as a judge. And in fact, given the same instruction, of course, there is some randomness in LLM's outputs, but to some extent, it's less susceptible to subjectivity in human annotations, which may be important, especially for more subjective judging tasks like evaluating personalization and so on. Another very important advantage of using an LLM as a judge is, I think, enabling of automated and dynamic benchmarking. So those of you who have been using publicly available benchmarks, you might have noticed that, for instance, I work a lot on conversational system research or search engine research, and the benchmarks available are often static. What I mean by that is they assume that given the first query, the system generates one response, and this next request by the user is fixed. So they basically provide you the sequence of interactions fixed by a user. But this quite often does not hold in reality when you develop a new conversational system, for instance. So the first request goes to the conversational system. Depending on the model that you have developed, the response may be different than what is in the benchmark. Not only that, the next query issued by the user would also be different depending on the previous response generated by the system you are testing. So this dynamic sequence of questions or queries submitted to a conversation system does not really hold when you are working on these type of systems, especially when your goal is to evaluate the quality of entire session or entire conversation history, for instance. So with using LLM as a judge, you can basically simulate these dynamic interactions by the user. And instead of having this fixed sequence, by using an LLM, you can simulate this dynamically changing requests that come from users and develop adaptive, dynamically changing benchmarks that are much more suited for evaluating this type of tasks, such as tasks in context of conversational system design. So these are some of the advantages of using an LLM as a judge, and based on this, basically a lot of recent research has been devoted to understand whether we can use LLMs as a complete replacement or as an alternative to human judges. And some recent research claim that LLMs tend to exhibit similar performance to expert annotators for tasks such as relevance assessments, which was a great thing because basically once this paper was published, for instance, a lot of people thought, oh, okay, we can just completely replace human annotations. No need for that. LLMs have very similar performance. So let's just use an LLM as a judge as is. And some other work also showed that LLMs could perform even better than crowd judges on certain tasks. And again, this suggested that maybe we can completely replace human judges, no need for annotations. But then the question is, are LLMs really truly capable of replacing human judges? Do we need to basically look into possible issues that come with using LLM as a judge? And what are the mechanisms that we could use to ensure quality when using LLM as a judge? So for the rest of this talk, I'll try to talk about some of these possible limitations that might come when using an LLM as a judge and try to kind of attract attention that we have to be careful about when using these models instead of just saying, okay, they can completely replace using human annotators. Trying to think about some of these possible issues that might arise and also some possible mechanisms to improve these issues, these limitations. So a few possible limitations that I'll talk about today that one might face when using an LLM as a judge is one is quality of judgments. And second is the significant need for improvement, especially for multimodal tasks. Possible biases one might have in judgments obtained from using an LLM as a judge. And the possible biases one might get in evaluation results obtained by these judgments caused by the possible biases in judgments. So let's start with the first one, the quality of judgment issue. So on aggregate, previous work has shown that yes, LLMs tend to be quite highly correlated with the judgments obtained from humans. But if you look at in more detail, LLMs they have a tendency to assign higher scores to bad responses in a sense that they are a lot less strict than human annotators in lots of relevances, in lots of assessment annotation tasks. So here you see a plot. This is just an example on one data set that we have gathered. So here we have, this is relevance assessment task in context of search. And we have labels obtained from expert annotators. These were experts whose main job was basically to annotate. These are employed by National Institute of Standards and Technology in the US. And as I mentioned, their main job is to basically do annotations, and they are paid for that. And we try to compare the labels obtained by from these expert annotators with labels obtained using an LLM as a judge. So this is just one data set, but the results are quite consistent across different data sets. And this is one of our papers. In parallel, we noticed that some other researchers have reported similar issues. What this plot is showing is x-axis is the label assigned by human, the blue purplish one, versus GPT-4 using LLM as a judge. And the y-axis is the proportion of labels assigned to each category. So you can see that overall GPT-4 is a lot more likely to assign labels that are higher than grade 0, which is basically non-relevant category. And humans seems to tends to be a lot stricter, and they are much more likely to assign grade 0, non-relevant or bad category. And like I mentioned, this seems consistent across different data sets. And what this is showing is that in general, human assessors tend to apply stricter criteria in assessment than using LLMs. And what this is also suggesting is that our evaluation results obtained using an LLM as a judge could have a lot less discriminative power than when using human annotations. In the sense that imagine, for instance, having two different search algorithms, and one of them is retrieving somehow okay results, not really perfect, but they are somehow relevant, so not necessarily non-relevant. Whereas another search engine algorithm is retrieving completely rubbish results. If you were to use an LLM as a judge, very likely these two algorithms will be basically classified as similar quality because LLMs tend to assign labels greater than 0 to most results. Whereas if you were to use a human annotator, the human annotator would be able to discriminate between these results. And this could be a problem both for system evaluation as well as for model training. Another issue when using an LLM as a judge is that most LLMs are susceptible to judging non-relevant sentences or documents as relevant for tasks such as search relevance assessment or, for instance, in conversational system quality assessment if query words are inserted at random positions. Basically, LLM as a judge doesn't necessarily often care about the model having meaningful sentences, for instance, depending on the instructions, of course. And because of that, it's much easier to trick these models and to develop algorithms, even models that could generate outputs that could trick these algorithms and making these models think that they are better than others, basically. And this is a general problem, and quite a few people you might be already aware of it. They started even tricking these models using these type of approaches by hiding these query words, for instance, in the text, just embedding them so they are not visible, but they are somewhere there and so on. So this is one problem, quality of judgments. Even though in aggregate they look highly correlated, if you do a bit of deep dive, they may not be the best quality. And this quality issue becomes even more of a problem when you look at multimodal tasks, actually. As you know, lately, a lot of research has been devoted to using multimodal models for multimodal tasks. And yet, multimodal models, of course, come a little bit behind compared to text-based models. And when we look at using multimodal large language models, MLLMs, for multimodal evaluation tasks, they tend to demonstrate reasonable performance actually as judges on pair comparison on image to text tasks. What I mean by that is you have one image, like you see an example here, that's input to the system, and the output is expected to be a text. It could be, for instance, what is shown in this image, for instance, and describe this image and so on. So input is an image, output is a text. And the pairwise annotation task in this case is given two outputs, which one is better? And multimodal LLMs do perform reasonably well in this pairwise comparison task, and they were shown to achieve around, for instance, 79% agreement when compared to human pairwise annotation tasks. When you go to scoring tasks, where given a single output, you are asked to evaluate, is this a good response, somehow good response, or bad response, and so on. The agreement is slightly less, but still a bit reasonable, like 70%, for instance. If you go towards ranking task, where the goal is to basically, given a bunch of candidate responses, generate a ranking of these candidate responses, the quality drops significantly. So LLM as a judge, multimodal LLM as a judge approaches are not really good at evaluating ranking tasks. So this is still okay, given that we do reasonably well on pairwise comparison and also on scoring tasks. But the issue becomes much worse If we focus on multiple modalities, so here are two separate tasks. One is multimodal understanding tasks, where the input can be from any modality. It could be text, image, video, audio, and so on. But the output is always text. So the task could be, for instance, things like tell me what this does this audio video capture, for instance, or audio to text, generate a response based on the audio given to you, like the cultural associations you have with this audio and things like that. So this is multimodal understanding task. And another task that researchers have looked at is the generation task, multimodal generation task, where input could come from any modality and output could come from any modality as well. So the task here could be like text to image, image to video, audio to video, things like generate a video associated that reminds you or that could be associated with this audio, for instance. Given this text description, generate an image that could be based on this description and so on. So multimodal tasks such as these are becoming more and more common. But if you look at using LLM as a judge or multimodal LLM as a judge in such tasks, the quality of using multimodal LLM as a judge is significantly worse in such multimodal, multiple modality tasks. So in multimodal understanding, models tend to still perform reasonably well, where they achieve average correlation of like approximately 66% on pair comparison, and 42% is still quite low on score evaluation in multimodal understanding tests. Remember that was multiple modality as input, just text modality as output. But this correlation becomes much worse on multimodal generation task, where input comes from any modality and output could be also any modality. So this is a significant problem, and especially for researchers who are working on multimodal tasks, if they are just relying on using multimodal LLM as a judge, they have to be a bit more careful and they may need to employ different approaches for this. And in general, of course, multimodal models is an active research area, development of further improved models. And I think over time this may get better, but at the moment there are possible limitations regarding using multimodal LLM as a judge approaches. And as you can see, still on pair comparison, models tend to perform much better than scoring evaluation on an individual item, similar to image to text tasks. But quite often you do need, especially for model training in lots of tasks, score evaluation is the primary thing that you might need. One thing that I think lots of researchers have to work on is regarding improving quality of using multimodal LLM as a judge approaches. And overall, again, this is quite important because this could have significant effect on model development. If you, given that we are using these approaches to decide which model is the best performing approach, for instance, or which model is, should I pick among a set of candidate models if you are using them for deciding which model to deploy or use in production system, this could be a major problem. Another major limitation of using LLM as a judge is possible bias in the judgments obtained from LLMs. And in general, previous research has shown that LLM judges tend to prefer responses generated by LLMs. This is not really surprising because, as you know, LLMs tend to be trained using similar approaches and using similar data sets. Yes, there are some variations in objectives used by these models, but quite often they have similar objectives and they use similar public data sets or similar data sets, even private. And so overall, their architectures are quite similar, and which means that they may have a tendency to prefer responses that come from other LLM-based approaches. And this bias could become even worse when identical models are used for response generation and judging. Meaning, if you are using, for instance, a GPT-based approach in in response generation, and if you are using another GPT-based approach when doing the judging for LLM as a judge, there is a high chance that your LLM as a judge will favor this GPT-based approach. This is quite an important issue actually when using an LLM as a judge because first of all, if you are for instance, you may be comparing using an LLM-based approach with more traditional machine learning-based approach, for instance, and your evaluation results could just show you that your approach is performing better than other approaches just because it's based on LLMs. And not only that, for instance, you may be using a better, there may be a better approach out there, for instance, for in context of research or when you are developing a new model for production. Just because you are using the same model as the one that is used evaluation in LLM as a judge task, in the judging task, you may make wrong decisions and you may incorrectly decide that this approach that you have developed is better and deploying wrong systems. This is unfortunately something that is completely ignored by both practitioners and researchers. Uh, and uh, and one issue that we have to be careful about is the fact that whether we are using the same exact model in system evaluation and in system generation. And another issue with using LLM as a judge is that LLMs tend to favor longer responses, for instance. This is just one type of bias. There are other biases as well. For instance, if you are to use LLMs for tasks such as judging verbosity, LLMs are not the best models because of the way they are trained. For instance, if you are using an LLM as a judge to judge the quality of a voice assistant, typically the way users interact with voice assistants, since the interaction mode is over voice, and the type of responses they would expect would be different than when they interact with a text written interaction, for instance, just a regular chat interaction over text. And this type of verbosity issue could become a problem in this case because most LLMs are effectively trained mainly on textual written text, and they do have this tendency to prefer more text-like, written text-like or textbook-like interactions, for instance. And this is another issue that has to be considered when using LLM as a judge. So a lot of this work that I have been talking about here are mainly based on research done on textual models, but similar biases were observed when using multimodal LLM as a judge on multimodal tasks as well recently. So this is bias in evaluation, in annotations that are obtained. One question you might ask is, yes, there are these possible biases, but how does it affect evaluation results overall? And for that, what we did is we recently organized a challenge organized by as part of the TREC Test Retrieval Conference funded by National Institute of Standards and Technology. This is a TREC deep learning track where the task here is on passage retrieval, where the participants are expected to retrieve or generate a rank list of passages given a query. And lots of different participants participated from all around the world. And in this case, what we try to check is to see whether using an LLM as a judge results in more biased evaluation results compared to using human expert annotations. So x-axis here are our evaluation results obtained if you were to use human experts in evaluation, where these human experts were highly trained NIST experts funded by NIST. And the y-axis here is evaluation results that we would obtain if we were to use an LLM as a judge approach. So here the labels are obtained using GPT-4. And each dot here is a different system submitted from different researchers all around the world. And we categorize these systems based on the type of models that they have used. For instance, GPT-based models, GPT plus T5, T5-based models, or other models. And we evaluated each of these systems using two different evaluation metrics. One is NDCG at 10, a commonly used metric used in evaluating retrieval quality, which focuses on top 10 results of a ranking, and mean average precision, which focuses on overall quality. And what our results have shown that, first of all, using GPT-4 based labels, evaluation results tend to significantly overestimate the quality of models. So this is also related to the fact that LLM as a judge approaches tend to be a lot less strict than using regular human annotators. And this seems more or less consistent. It's worse if you focus on NDCG at 10 as a metric, which is looking at the top 10 rank results. If you look at overall result quality, it's a little less, but still, the overestimation is still out there. Another thing our results showed is that, for instance, this type of overestimation issue is worse for models that are based on GPT, same model as the one that is used in evaluation. For instance, here we use GPT-4 for generating labels, and the overestimation tend to be worse when we use GPT-4 model, when we use these labels to evaluate GPT-based models. So this is quite worrying actually, because it could suggest that we may be incorrectly, like for instance in this case, we may be incorrectly, or in this case, selecting these models or these models as the best performing models, even though they are not. They are significantly worse than top performing models possibly. And so given these results, we try to do some analysis to better understand what are these factors that are causing these biases that we observe in the evaluation results that we have. And for that, we try to identify the different factors that could cause significant deviations from evaluation results that we would have obtained if we were to use human judgments. So we use a linear mixed effect models to assess differences in metric scores when using evaluations obtained using human annotations as a reference. Here, Yij is the score evaluation result of using of system I on query J, for instance, and we try to identify different factors that could cause these issues, such as whether the system was judged by GPT-4, which is one of the things we are looking for. System type, is it a GPT-based system? Is it a GPT-5-based system? Or is it a combined system? And so on. Is it the difficulty of the query? Because one of the things we know is that LLMs tend to be a lot less strict, but does the difficulty of the query have an effect? Basically, is this deviation from human judgments more significant for queries that are more difficult, for instance? So query difficulty is one factor we looked at. Number of query words, because as number of query words increase, again, queries may become a bit more difficult. And also LLMs tend to have this verbosity bias, and overall, does it make a difference if the query is also verbose? And document length, again, due to this verbosity bias, do LLM-based approaches tend to prefer significantly lengthier responses, which could be documents or passages, for instance, in this case? Or is the query generated by GPT-4? We also analyzed some artificial queries generated by these models, which is not the focus in this talk, as well as like, is it a combined model? Does it use a combination of different approaches, for instance, and so on? And we also looked into interactions of these effects, like is it a GPT, is it judged by GPT, and is it a GPT-based system, and so on. And here we analyzed three types of systems: GPT-based, T5, GPT plus T5 systems, and try to check which of these factors had caused significant deviation in evaluation results obtained compared to human evaluation results. And what we found is kind of aligned with some of the things that I was describing, which is that factors that play a significant role in evaluation results is one, whether the evaluation results, the LLM as a judge annotations were obtained by using GPT-4, whether the system type is GPT or is it a combination of GPT and T5. So GPT-4 seems to be basically favoring GPT-based approaches, for instance. Query difficulty, again, if the query is more difficult, because LLMs tend to be a lot less strict in judging, this gap seems to be open up compared to human evaluation results. Document length, as expected, again, LLMs have this verbosity bias, and that they do tend to, our mixed effect models analysis also show that they do tend to prefer these higher documents. And interactions, different interactions of these. So what does this mean then? Yes, there are some biases that are present when using LLM as a judge, and these biases could have significant implications for system development, basically. First of all, as I mentioned, we could end up deploying bad systems, or we could end up claiming incorrectly when we publish our research that our work is better than existing work, just because our model is using the same model as the one used in LLM as a judge. In fact, that could be a way for researchers to possibly trick even these publishing, which most reviewers won't necessarily consider, but same in production environments. And also just because they are based on LLMs, especially when comparing with traditional approaches, for instance. What this is also suggesting is possibly even worse, which is that results presented to users could over time get dominated by with responses generated by AI. What I mean by that is, as you know, search engines or conversational systems are kind of primary mechanisms now that a lot of us are using to access information. And most of these models are based on possibly LLM-based approaches, or even if not, most of them are often trained using LLM as a judge approaches. And what our results are showing is that if you use an LLM as a judge in evaluation, very likely these models will favor LLM-based, LLM-generated responses. And as you know, internet is currently dominated with AI-generated data. And this might mean is over time, because we are kind of telling our search engines or conversational systems, for instance, and so on, in our evaluation setup that they should be favoring, or the AI generated content is better than human written content, then over time, these models will learn to favor AI generated content. So when you submit a search engine query to a search engine, or when you ask a question to a conversational system, quite likely it will rely a lot more on AI generated content, and which could possibly be prone to hallucinations and certain biases, and possibly less reliable than human generated content, and which might possibly have an effect in shaping how society thinks, basically. And this is highly relevant to one active research area that we have also recently started looking into, which is model collapse, where these AI-based models, or even foundational models trained using data generated by LLMs, tend to become worse and worse over time, or exhibiting more biases over time, just because the internet is becoming more and more dominated with AI generated content. So just to clarify, basically, as you know, LLMs are often generated or trained by using open text like Wikipedia and so on, or just any data available online, for instance. But a lot of the data available online is actually quite often generated using AI lately. And in model collapse, the idea is that as you train these models with this type of AI generated content, and even if you use, for instance, RAG-based architectures or search engines to select better or higher quality content because they are favoring AI generated content, model collapse says that over time, when we use this data to train our foundational models, they are more likely to kind of overfit or face more issues that are faced by AI based content, such as being more verbose, or more the type of biases that AI based approaches face. So that's one research area that we have recently started looking into. Okay, these are some of the issues of using, or limitations of using LLM as a judge. And I know I don't have too much time, but I would also like to briefly talk about how can we improve these issues, these limitations. There is no perfect solution, actually. And as you know, even humans, even if you use human expert annotators, they have their own challenges in terms of quality. Even if you ask the same human over different times, the same expert annotator may give you different responses. So there is no perfect solution that will be like the perfect thing, but there are some ways that we could explore in order to improve the issues with using LLM as a judge. So one is, of course, this is very simple, but quite often forgotten. The simplest thing, at least we could do when we publish a research paper, for instance, or when we deploy our models using and based on LLM as a judge evaluation results, is to use human assessments to continuously monitor quality of LLM as a judge, to at least check whether is this LLM as a judge uh, able to do this annotation task. Are the instructions that are given to it reliable? Does it exhibit biases? How does it compare if I were to use human experts, for instance, for comparison? This is quite often ignored, but I think is extremely important, especially given the results that I have just presented. And that's the simplest thing we could do. Other things we could do is one is to utilize the power of multiple models to improve problems with quality and bias. Or another recent approach is to use an agentic approach to evaluation. So we have been using multi-agent architectures or agentic architectures for response generation. But similarly, these architectures are quite valuable and they have a lot of potential when developing when developing annotation approaches or using LLMs as annotators as well. So just briefly, how can we utilize the power of multiple models? We have explored many simple ways of doing it actually, just very simple approaches at the very beginning, which is basically the simplest thing you could do is to basically employ different prompts. So same model, different prompts. And we know that different prompts may bring in different perspective to LLMs, for instance, and this could help reduce quality issues of just using a single prompt, or this could also possibly help eliminate issues related to bias in judgments, because one prompt may bring in one bias, but possibly having multiple prompts or multiple perspectives, this bias issue could disappear. Another thing is that can be used is to aggregate possibly multiple models, so that maybe we can use multiple smaller models and aggregate these multiple output of these multiple small models to generate a single higher quality response, for instance. And this is based on some recent work, very simple. I'm not going to get too much into details of this. I don't have too much time, but basically we have explored if we were to use different prompts for the same model, can we get better quality compared to if we were to use, for instance, smaller models? Because of course there is a challenge, even though we say LLMs are less costly and less expensive. This is still, especially for tasks where you require lots of annotations, this still could become a problem. So can we, by utilizing these smaller models, can we reach performance, or can we overcome some of these issues associated with using a single small model, for instance, or can we reach the quality of a single large model, for instance? Or if we were to use different models with different models, because typically different models work well with different models, and aggregate the scores, can we reach a good performance at the end? So very quickly, so this is our baseline model, single large model, best performing. And we tried smaller models, we tried fine tuning using different prompts, or we try to combine the output of different large language models, small models. And the results are interesting actually. You could perform just by using different prompts on the same model, you could perform close to best performing large model, for instance, and you perform better than fine-tuned version of this model, for instance. And also by combining outputs of different small models, you could actually outperform the performance of the best performing large language model when using LLM as a judge. So here you see Cohen's kappa compared to human annotations, annotators. So that's one possible approach. Another possible approach that you could use, and I think this has a lot of potential, is debating. So basically, you can ask multiple LLMs to debate with each other, and so that you can basically have another LLM watching this debate, for instance, and make a final decision in the evaluation task. So each LLM here, debating LLMs, is assigned to support one side of an argument or to generate certain argument, and the final judge that makes the final decision is watching these arguments and makes the final decision based on these arguments that are out there. And so this work has shown that basically by utilizing the power of multiple models, LLMs debating could result on significant improvements compared to using LLM as a judge. And I really like this work actually, and it has a lot of potential. So the researchers that have started looking into this, mainly focused on specific tasks, but I think there is a lot more potential here to be explored. But there are a few things that one also has to be careful about, as pointed out by the researchers of this paper as well. Since LLMs are not typically trained to debate, you have to be very careful when you specify the rules of the task by asking the model to support a side, by asking the model to generate arguments and rebuttals that are backed by logic, facts, and evidence, and the answers that it generates should be convincing, factual, and concise. So just using an LLM as is not may not be ideal. You have to kind of tell the model to explicitly debate in a sense. And one more thing to be careful about is again this issue with bias, especially if you are using the same model as the final judge that makes the final decision, and use the same model as the debater which generates the debate arguments. Quite often what you will see is that final judge will prefer the argument by the debater that comes from the same model family. So basically an LLM judge consistently favoring the side with the same LLM backbone in the debate. And to avoid that, there are two things that can be done: either to use completely homogeneous or heterogeneous models, or making sure that the judge model is asked to state the main reason for its choice, so that the decisions it makes are not based on this model similarity, but more on logical reasons. Again, I think this work has a lot of potential, but it's not used as much as it should be in practice, also because of possibly of the costs associated with debating. Another recent work, and which has a lot of potential, I think, is agent as a judge, as opposed to using an LLM as a judge. So I'll be very quickly go over this idea, which is basically suggesting that instead of just using a simple LLM as a judge approach, we should use an agent as a judge approach because of its proactive nature and memory, which of the agents, which involves using memory and so on. So one issue with using LLM as a judge is that they are a bit too simplistic. You have these instructions, they do just single forward pass, and they mainly do stylistic or snapshot evaluation, which they are good for these tasks, but quite often for more complex tasks, they are not really adequate because they cannot use tools. They cannot execute things. Sometimes certain evaluation tasks may require executing tools, like fact checking. For instance, you may have to issue multiple searches. You may have to combine multiple sources of evidence. You may have to execute APIs, for instance, and certain tasks also require using memory, especially tasks that involve multiple steps that span different time periods. For instance, especially complex tasks like tasks involving, I don't know, trip planning and so on in conversational system setting, or tasks where I give an instruction now and I ask the model to proactively, for instance, inform me in a month from now and so on. So LLM as a judge approaches can be too simplistic to capture these type of tasks. Whereas if you use an agent as a judge, because it has memory, it can kind of keep track of complex tasks that span different time periods. It can handle tasks that involve asynchronous task execution, tasks involving personalization and proactivity, especially tasks where long-term history, where history means, by history I mean not just very recent history, but much longer relevant history is needed, or fact-checking tasks where multiple searches to validate the reliance or reliability of certain claims or outputs are necessary. In this type of task, LLM as a judge is unfortunately not very reliable. And some recent research that was published at ICML, not from again my group, but another group, showed that using agent as a judge could lead to significant improvements on code generation tasks. And one of the research areas that we are looking into is extending the potential of these agent as a judge approaches, which I don't think are fully utilized. And in fact, some of our current research is based on devising these advanced evaluation approaches, where instead of just looking at the final answers, especially in architectures, multi-agent architectures, instead of just looking at these final answers generated by models and treating the architecture as a black box, can we design advanced evaluation mechanisms for more enhanced optimization, where instead of just looking at the final output, we devise evaluation metrics that incorporate latency and cost of the model together with effectiveness in evaluation and optimization of multi-agent architectures or LLM-based approaches. And another recent work by my group also focused on devising a multi-agent evaluation framework for trajectory level evaluation, where instead of again just looking at the final output of a multi-agent system, for instance, trying to systematically assess errors in intermediate reasoning steps and coordination steps in a multi-agent architecture, so that we can convert these trajectory credits into suggestions for prompt improvements, so that each of the agents in multi-agent system can be improved by using these trajectory assessments. Okay, as a summary, in this talk, I try to focus on using LLMs as judges for evaluation. And as I mentioned, there are lots of potentials with these models, and they do enable us to scale and speed up model development. And yet we have to be somehow careful when using LLM as a judge approaches for evaluation. And unfortunately, a lot of researchers, both in academia and practitioners, they tend to ignore some of these issues, which could cause lots of wrong decisions made by just relying on these simple LLM as a judge approaches without monitoring their quality. And there are certain issues that could come up when using LLM as a judge approach. Issues related to quality, bias in judgments, bias in evaluations, and especially quality issues when using multimodal models for evaluation in multimodal tasks. And in these talks, I also try to talk a little bit about some of the possible ways that can be used to improve limitations of using LLM as a judge, such as using LLMs in combination with human assessors, which is the minimum that can be done. Like get a small subset. Of course, it's impossible to judge the whole set, but a small subset, check how well they compare with human assessors, and that would at least give you a bit of assurance about the reliability of the data, or utilizing the power of multiple models to improve problems with quality and bias. And finally, I briefly talked about agentic approach to evaluation, which I think has lots of potential to further improve the quality issues that come with using an LLM as a judge. Thank you very much.